Today we're doing the second set of notes of radicals, and we'll be talking about all the different properties of exponents. So the first kind of review that we're going to discuss, notice on the left-hand side I give you the property, and on the right-hand side we're going to apply said property. So on the left side it says if you have two bases that are the same, that you will be adding your exponents. So here I have the same bases, which means I will add my exponents, and this will be x to the fifth power. The next one says if you have a power raised to a power. So notice you have a power here raised to a power, that we multiply the powers. So this will be y to the 3 times 2, which equals y to the 6th power. And then the third property kind of puts the second property kind of applies here. So notice I have two different bases. So a and b, it could be like a number and a variable, or two different variables or two different numbers. And if you have that, then you kind of distribute your exponent into each base. So for here, I have two bases. 4 is a base and x is a base. So this will become 4 to the 3rd power. And then it'll be x squared times the 3. Because there was already a 2 in there, so we multiply them. 4 to the 3rd power is 64. And this will become x to the 6th power. Now we're going to take these properties and we're going to practice them, but now we're going to apply them with exponents that are fractions, kind of tying in the first set of notes. So again, here I have the same base, so I add my exponents. So this will be 8 to the 2/3 plus 1/3. We need common denominators in order to add fractions, which I have. The 3's are the same, so this will be 8 to the 3/3, which is just 8 to the 1st power. For the second one, again, power to a power says I multiply the exponents. So this will be 5 to the 1/2 times 4. When we multiply fractions, we multiply our tops and bottoms of the fractions respectively. So this will be 5 to the 4/2, because I multiplied the 1 and 4 and the 2 and 1. And this will be 5 squared, which will equal 25. And then again, the third one, I have two bases, 9 and x. I distribute that 1/2 into the exponent. So this is 9 to the 1/2 power and x to the 1/2 power. And remember, raising something to the 1/2 power means we're taking the square root. So this means I'm taking the square root of 9, which is 3. And then I'm going to rewrite this as the square root of x, because we talked about the 2 and the 1 go there. If the directions say put it in radical form, that's what I'm looking for. If it says leave it in exponential form, you could say 3x to the 1/2 power. So you now have 3 practice problems. Go ahead and try those. So moving on to day 2 of the radical notes. Notice at the top of your page we have a quick little recall. So this was something that we did in the first set of notes. The left-hand side again is our exponential side. The right-hand side is our radical side. You have to be able to convert back and forth between the two forms, and we talked about that quite extensively. So, coming over to my first example, I'm going to fill in the numbers that are missing. So because it's a square root, I'm going to put my 2. That's technically y to the 1st power, and over here that's y to the 1st power. So I'm going to rewrite this as exponents. So this will be y to the 1/2 power times y to the 1/4 power. In order to use the exponent rules, I need to see exponents. Now that I have the same base, we are going to add my exponents. But in order to add these, I need common denominators. So we are going to multiply the right fraction, top and bottom, by 2. And we're going to multiply the left fraction, top and bottom, by 4. By doing this, we will have common denominators. So this will become 4/8 plus 2/8. And when I add that, I get y to the 6/8. Now we can reduce that, and I expect you to reduce if you can. I'm running out of room, so I'll come up here. So this will be y to the 3/4 power. But notice the directions say write your answer in radical form. So to put this back in radical form, this will be the 4th root of y cubed. And that is our final answer. For letter B, I'm going to change the problem slightly just so that we have a little bit more of an example to look at. So we're going to make this inside root be the fifth root. So just add that little 5 on your notes for me. And we're going to work inside out. So we're going to kind of focus on this inside radical first. So to put that in exponential form, this will be 2x to the 2 over 5. Now, again, I'm going to fill a 1 over here for the outside radical. So the radical that's out there, well, there's a 3 and a 1. So to replace that, I'm going to write to the 1/3 power. So remember that whatever the root is always the bottom number of our fraction. And now, when I have a power raised to a power, I multiply my exponents. Multiplying, we just multiplied tops and bottoms respectively. You do not need common denominators to multiply. So this will be x to the 2 over 15. And again, to put it in radical form, I will rewrite this as the 15th root of x squared. And that is it for letter B. For letter C, again, I'm going to go through and I'm going to fill in any numbers that are missing. So this 1 goes with the 16. I'll fill that in. And I have 3 different bases, and all 3 of these are underneath the 4th root. So I'm going to start by writing them in exponential form. So it will begin with 16 to the 1/4 power, x to the 2/4 power, and y to the 3/4 power. 16 to the 1/4 power again means the 4th root of 16, which will put me at 2. I can reduce the fraction for x to be 1/2, but the y cannot reduce. Now, I would accept that as an answer because the directions say put it in radical form. I will do that. So to put this in radical form, this will become 2 to the square root of x and the 4th root of y cubed. The reason I can't put x and y underneath the same radicals is because they're two different. One's a square root and one's a 4th root. So go ahead and try those practice problems. Obviously hit resume when you are ready. So the next thing we're going to talk about is negative exponents, and I don't believe this is something you have ever seen. So notice the rule is off to the left-hand side. So this says if I have a base raised to a negative exponent, then I move the entire unit down to the bottom of a fraction, but I make the exponent positive. So for this first example, it says x to the negative 4th power. This means the problem will become 1 over x to the positive 4th power. So the negative exponent moves its place in the fraction. Just to kind of give you another example, if I had 1 over x to the negative 7th power, again, if I wanted to get rid of that negative exponent, I'm going to move its place in the fraction. So right now it's on the bottom. So if I move its place, it will now move to the top. So this will become x to the 7th power. So again, the negative just moves your place in the fraction. So here, this next one, again, I'll start by saying 1 over x to the positive 2/3. And if I want to put that back in radical form, it would look like 1 over the cube root of x squared. So if you flip the page, again, you have 4 practice problems. Go ahead and try those, and you will input your answers in the video.